Hi everyone, I'm David Horler and I look after the team that develops FESafe and the 3D Experience durability apps that expose the FESafe capabilities in the platform. And I'm going to actually cover a little bit of both here, and in fact you will see I start mostly with the 3DX. So the basis of this legal notice is that anything that we're saying that is coming soon, for example, there's still some risk that it may be delayed, things like that. That's generally the main thing here, right? So what am I going to cover? I'm going to go through what we've exposed in the 3D Experience platform for a while, and then I'll focus on, most of the rest focuses on FESafe itself, some of the things we've done in really Verity weld fatigue, vibration fatigue, something about the nitinol plugin we've created, a new TCD or Theory of Critical Distances interface. I'll give you a list of some smaller general enhancements, and then I'll give you a glimpse of what's coming in the next month or so, in releases that are coming out in the next month or so. So the main project we did in the 3D Experience this year was to add FKM guideline weld assessments for solid models. This gives you, this model you see in the picture has many welds. Just some of them in the sort of pale bluish green are highlighted around the connection to the boom of the of the excavator. And you have your normal feature tree. There's the feature manager, the fatigue loading. I'll talk a little bit more about that later on. For those of you, I think most companies are either FKM style approach or they're non-FKM style approach. If you're FKM style approach, you understand that the FKM guideline has a lot of control parameters that you can play with. All right, in an earlier release of FKM capabilities for base metal fatigue, not for non-welded structures in FESafe, we thought most people would take the default lookup tables and so forth, and that turned out to be wrong. This time around, we said, okay, we're going to expose every one of the parameters. We have suitable defaults in every case, and we try to use the exact same symbols that you will see in the guideline. Okay, we will not document. Our user document doesn't cover all of the FKM parameters because the expectation is that you have your own copy of the FKM guideline. Okay, and you have to have that guideline because it gives you guidance on how to choose the values here if you're not going to choose defaults. Okay, so one thing to notice here is whereas FESafe traditionally has only ever done fatigue assessment, this is the first time we've actually added a static strength assessment as well for FKM-based weld assessments. All right. So just a little sort of a summary, so just a reminder, this only applies to solid models at this point. Static and fatigue assessments here. We use the local structural stress approach. We do not use the nominal stress approach. So, I mean, really what that means is the structural stresses are computed either by using surface stress extrapolation per the IIW recommendations. These are the same kind of techniques used in FKM and the British standard and various Euro codes and also in other standards. You can also use, sometimes you can't use surface stress extrapolation if your welds are too close to the edge and there isn't a long enough distance to do extrapolation. or if your welds are too close together, or it's just too close to some other discrete feature, and then you have to switch to through thickness linearization. Okay, it's also in most of these standards as an alternative. So I've already mentioned that we provide you with maximum controllability of all the FKM parameters. Each FKM durability case can have any number of weld assessments. So we kind of have an assessment concept that's basically like an abacus step, and it's not so sequential evolving as you have in abacus. They're basically independent assessments, but it allows you to do a lot of assessments all in one sort of job submission. You do have to model the weld fillet in the CAD model, and you are required to make compatible meshes across the interface between the weld and the plates being welded, in other words, across the fusion interfaces. So the usual advantage, of course, but with 3DX is that you're integrating with CAD and data management, but in this case, you're also integrating with the mechanical scenario app itself, with all the structural apps, so you can set up all your structural analyses, use them as many as you like to drive as many durability cases as you like, and then you just let it click OK here, and it'll automatically chain all of the structural simulations and the durability analyses. Okay, the structural simulations, of course, run Abacus in the background, and the durability calculations are actually running the FE-Safe fatigue engine in the background. So we can cover, at this point, almost all of the fatigue loading options that are in FE-Safe within 3DX. You can actually set up load histories in the PLM system and then share them amongst multiple simulations because they're in the data management system. Last year actually a different team went and rearranged the material options so that we basically cover all of the Abacus, pretty much all of the Abacus material options now under these categories, and now we've grouped all of the fatigue capabilities under the FE-Safe durability higher level option here. All right, we cover pretty much all of the base metal capabilities in fatigue capabilities in FE-Safe are covered in 3DX. We have these more general options that today are only used with FE-Safe, with their durability. In the future, they may actually be used in other designer-related products just for structural stress calculations. You can we cover all of the mean stress corrections, finite life, infinite life, all of those options. You can actually define multiple behaviors. So you might choose a behavior that's mostly suitable for the same material, right? You choose one behavior that's targeted for a low cycle fatigue regime and another behavior for high cycle fatigue regime, right? Or finite and an infinite life. This is not specific to durability. This actually applies to general structural simulations, right? So you might use one for an NVH kind of situation and a different one for an ultimate strength use cases, right? You might have different material behaviors. The one would be mostly linear, of course, if you're dealing mostly with NVH. And if you're doing ultimate limit states, you would typically include nonlinearities in that kind of situation, right? As I said, we cover nearly all of the loading capabilities in FESafe, the superposition, sequences of frames or data sets, as it's called in FESafe. For FKM, we allow you to specify a spectrum events directly, and you can overlay events, for example, having a higher frequency cycles superimposed on some lower frequency cycles, right? In FESafe, those are called high frequency events, but ironically, some people would use the high frequency event for the low cycle and use the regular event for the higher ones. But anyway, so and the preloading effects, including residual stresses and stuff, can of course be included. We recently added temperatures. Allows you to specify temperatures either as a uniform value, or you can specify a temperature frame that you want to apply to each event. I think I can skip some of this. So the material properties for 3D for durability are in the same material as they are in for the structural calculations or any thermal analysis you're doing in the mechanical scenario. We cover all of the surface finishes now. We had some limitations in earlier releases, but now we cover all of the FESafe ones. You'll see we actually expanded FESafe to allow you to define KT files as well as KF files. In a lot of the handbooks and so forth, some of them give you graphs in terms of KT values and some of them give you graphs in terms of KF values. We decided to go ahead and support the KF ones more directly. You can sometimes get better extrapolations off the ends using KF files. We had a limitation in the past where you had to use elements that had nodal integration, like the C3D10S element, for example, and the C3DHS elements, because we weren't doing extrapolation from the gas points to the element nodes in 3DX like we were with the ODB and FESafe, but now we've plugged that hole and now you can use any of the element types. We expanded the output options so that you can get the damage per event. That's often used by people who want to do their own manipulations in spreadsheets with damages from different events. A key factor, of course, in most of our development is prioritized based on feedback from customers, but it's even more heavily so in 3DX where it's driven by actual customer engagements. So now switching to FESafe itself, we're never not working on improving weld fatigue, basically. And the last years is no exception to that. We used to have trouble with this kind of geometry on the right where you had a fillet weld against a plate that had some kind of hump or rib along it. We would just fail to analyze that completely. Now we automatically can take this into account and we break it up into two segments and analyze the two segments separately. We had the ability to do where you could choose either just the normal stress to a weld line or the shear along here, right? You had to choose to do them separately in separate jobs. We now allow you to just say, look, just give me the worst of both cases, okay? So that's a sort of a poor man's multi-axial, sometimes good enough, I would expect for quite a few people. But we also now have the advanced multi-axial one where we do a multi-axial cycle counting using the shear, the longitudinal shear and the normal stresses. and blending of the normal shear and master and shear master SN curves. Okay. These different options are turned on under a new FEA fatigue analysis options, where you can choose which kind of weld algorithm you want to choose. We've left the default as the old one, being the normal, just using normal stresses. It runs the fastest, and it's the one most people actually use. So we've left that as the default. Depending on how feedback goes, we may end up turning on this advanced one, because you have less to do. It's more automated. I do want to remind people of something we released over a year ago, and this enhanced nodal force option. With the basic nodal force method, you have to have these perfectly structured meshes. Okay, where under the weld line node, you had to have the nodes lined up beautifully below it, or else you could turn on a lot of smoothing. We changed to what we call an enhanced nodal force method, where now you can use far less structured grids, but you do still have to partition along the crack plane. So if you want to have the toe failure through the plates here and here, you still need to partition that geometry so that we end up with element faces on that crack face. Okay. So this one's under vibration fatigue, but really it's a crossover with Verity again, because we now allow you to run Verity in the frequency domain, not just in the time domain modal dynamics style approach. We can now also use the PSD-based methods in the frequency domain. You can see we get good comparable answers between time domain and frequency domain for the welds. Sorry, there is a special presentation on this in quite a bit more detail that's in the Simulia learning community. Nitinol is often used in, this is a little element model of a stent that's put into your arteries. We offer a plug-in. It's not natively. We offer a plug-in to do infinite life strain-based method fatigue. There's a mean strain effect in it. Similarly to the last slide, there's also there's a webinar on recording on the Simulia learning community to find a whole lot more details about what we do there, and how you would go about setting up your abacus models, and as well as the FE-safe analysis and setup for Nitinol. Theory of critical distances. Some while ago, one of our customers told us it's really hard to understand the results because we would choose a suitable algorithm for crack initiation at the surface of the components and for the TCD calculation we would only ever do the normal stress method, and so you're getting two different algorithms at the surface and at the subsurface calculation where we do the TCD calculation. And sometimes you would even get the subsurface calculation showing you with worse life than you would get from your crack initiation life. So they were going to the extent of doing their own workarounds in the post-processor where they would just sample stresses at the subsurface levels based on, the material characteristic length or the critical distance length. So it's been on our plans for a while, and finally we got it done last year. Last month it came out. And now we use the exact same you just choose the algorithm in one place, and we do use the exact same algorithm. We run through the exact same code. In the past, we were even using slightly different critical plane code searches for the TCD calculations than we were doing for the surface calculations. Now we just run through the exact same code. While we were at it, we expanded the the mean stress correction options to harmonize them between finite and infinite life, for example, for the normal stress method, which is one of the more popular methods. So you can see the GUI here now. The other thing was that to turn on TCD, you had to step through about 5 layers of the GUI to just turn it on. Now it's right there, much more kind of a first-class feature, right? When you're assigning the algorithm, if you've chosen a FRF type infinite life algorithm, then you will automatically get this thing popping up. This was there in the past, but now you also get this extra button to turn on TCD. Okay. Similarly, in the factor of strength analysis, there's also a button to turn on TCD. Okay, so this actually allows you to run TCD with finite life algorithms. There is if you look at the critical distance, the material property, it does actually vary life, the number of cycles that the structure is going to experience. If you just go with the infinite life critical distance, you're going to be conservative. You may actually be too conservative because that distance actually increases typically quite substantially as you move towards a sort of lower cycle regime. Okay. If you are going to do lower cycle, non-infinite life, finite life calculations with TCD, it's probably wise to check with us before you do that, okay? Because it's definitely advanced capabilities, but we actually do have a couple of customers who've asked for it. You will also see now that in the analysis options dialog, there used to be you used to have to turn on TCD under a tab called safety factors, and then it mixed up factor of strength or FOS parameters with TCD parameters. Now we've separated that much more cleanly, so it's also a bit easier to understand. So some general enhancements in 20x 2020 releases. All our documentation, our defaults to help@3ds.com. I believe the documentation is still shipped in the installation, so you can actually use that if you prefer. Something maybe I'd have to check, but if you save rubber as had an update last year with several fixes. There's actually another handy fix coming in the next few months. We updated our ANSYS RST support to the latest. We had supported named sets or groups with the, if you're using ANSYS Classical, but we were not supporting what's called named selections if you're actually building your models with ANSYS Workbench and then producing RST files. And now we do that too. As part of the TCD effort in the past, people had said that some of their life predictions had a lot of shear in them, and we needed to take some shear into effect. We couldn't just use the normal stress kind of algorithm. So we'd added the Susma-Lazarin infinite life method. We now, and it was only at the TCD location that you could use that method. Excuse me. And now we just made that available generally as another general algorithm. I think I mentioned this already, and I mentioned this already as well under the 3DX thing. What's coming in the next few months? There's some unification to our licensing between FESafe and Abacus in terms of token usage and so forth. It does switch to a core count dependent licensing model. This is also being organized between the structural and the durability solves in 3DX as well. I'm sure there's going to be more announcements on that in general. And the other very big thing that's coming out actually next month. Yeah, next month is coming out is Verity line wells for shell models. In the subsequent release, we'll then cover solid models. So you can see a bit of a zoom in of a piece of a automotive chassis. You can see the shell weld fillets being modeled here. And here's a bit of a further zoom in where you can see the log life repeats plotted contours along the weld tow lines. There's actually quite a nice blog post at this location. This blog post actually deals with using 3DX to run the structural solves, and then it shows you how to combine that with using FESafe and Tosca to do some optimization of durability calculations. So it's using the established product FESafe and Tosca in combination with 3DX. Moving forward, of course, at least the durability calculation would actually be able to be done for these shell models directly within 3DX. So that's it for me.